So good morning, everyone. We are going to cover the remaining part from the ANN theory, and then we will, if possible, we will go for the implementation. So we have covered this part yesterday. What is ANN? Little bit history about artificial neural network. Then difference between the biological and artificial neuron. Then structure of a neuron, or how the layers are there: input layer, hidden layer, output layer. Hidden layer can be like one or more. Okay, so that is the thing. Next is how it works. Input layer, then we are just multiplying it by weights, adding the bias. Activation function is there in order to get the output. How data is processed in a hidden layer, output generation and learning process in the ANN. These are some of the activation functions. Those are used in a regular artificial neural network. That is a step function, sigmoid function, then tanh function, ReLU and softmax. Okay, sigmoid is just converting your output in either 0 to 1. So actually it will be a 0 to 1 values, but the threshold is of a 0.5. So it will be below 0.5, it will be a 0, and which is a value that is equal to or greater than 0.5 will be considered as a 1. Okay, ReLU is just having the maximum of 0 comma x, right? These are some of the neural networks that we covered yesterday, right? Most of the time CNN, ANN and RNN, on these things we are working. If needed, there is an extension of RNN, that is a LSTM, long short term memory, that with that we are working in some of the cases. Now we will see what is this perceptron model, or we call it as multi-layer perceptron model. Okay, so the perceptron model was the simplest type of a neural network. So this was very initial stage. In initial stage, it was called as the perceptron model. In 1958, Frank introduced it, and it is used for the binary classification problem, just true or false, yes or no, right? So it receives the multiple inputs, apply weights, add the bias, and produce output. Very simple, right? So we are having an input, we are multiplying it with weights, adding a bias, and it will give you the output whether person is a non-diabetic or diabetic. So this type of model are called as the perceptron model. So components will be very simple, right? We are having an input. Suppose cholesterol is there, then age is there, then blood pressure is there. Three inputs are there. The data is given to the model. The data is given to the model, and weights are like W1, W2, W3. Whatever values are there of input, those many weights will be there, and importance of each input will be defined by those weights, and additional parameter to improve the accuracy, right? How this accuracy improved? Suppose weight is initialized as a 0, and for some of the input it may give a value as a 0. So to avoid such a situation, what we are adding? Bias there, just like a intercept in case of linear regression, correct? Activation function is used to produce a final output. So there are certain activation functions. Suppose sigmoid is there. Please remember this. Sigmoid activation function is used for the binary classification, and there is something called as the softmax activation function. So that softmax activation function is used for the softmax activation function is used for the multi-class classification. At least remember this. Okay. So this is a simple working of perceptron. How it is working? Inputs are multiplied by weights. Weighted inputs are summed with a bias, and activation function is applied, and final output is generated. Okay. So activation function we need to use based on the whatever output is there, right? Suppose iris problem is there, I will go with a softmax activation function. This I need to define, okay, as a parameter. If suppose I'm just deciding whether person is a diabetic or non-diabetic, it's a binary problem, so I need to go with the sigmoid activation function. So this is how it will work. In order to train a ANN model, so training is just a process of teaching an ANN to learn a pattern from the data. So same, whatever we are worked in machine learning thing, so same way it will work. We are having some historical data, past data. Based on that, it will learn, and it will give us the future predictions. Okay, So during a training, network adjusts its weights. What will be adjusted? Which value will be adjusted? X will be fixed, right? Again, W and B will be changed. Optimized value of W and B will be chosen in order to get correct output. So values to improve the prediction accuracy. Same way it will work. We are just adjusting M and C. Is it optimized values of M and C are find out by using the suppose gradient descent. Optimizer is there. One more concept is there, that is an optimizer. So what optimizer is doing? Optimizer is optimizing the values of W and B in order to get a correct output. Are you getting? Yes. There is something called as the optimizer, which is optimizing the value. Suppose W new equal to, there is some formula, W new is equal to W old minus learning rate into derivative of a error or a loss with respect to derivative of X. Something formula is there. I will explain this formula in like upcoming slide. So steps in ANN training, or while we are teaching the artificial neural network, what is there first? Forward propagation, where input data passes through a network and ANN generates the output. Suppose what we are having, input layer, hidden layer, right? And we are having output, input layer, hidden layer, and output layer. Okay, so these are like interconnected neurons. This process is known as the forward propagation. This process is known as the forward propagation. Whatever output is there, suppose out of 100 value you got 80 correct, so 80% accuracy is there and you just want to increase the accuracy, then again weights will be updated. Again W1, W2, W3, W4, whatever values are there, those will be updated, and again you will get the improved accuracy. Suppose it is 85. So whatever process is there, whatever process is there, that error is sent back to the network, and weights and bias are updated in order to reduce the error, right? So 20% error is there right now. Initially in a first iteration, how much error is there? 20% error is there, and that error is minimized in a second iteration, so that whatever process is happening in a backward, which is updating the weights and bias, that is known as the backup propagation. So error is sent backward through the network and weights and bias are updated to reduce the error. So this weight updation formula, or like optimization algorithms like a gradient descent update weights. So there are some of the optimizers. Gradient descent is there, stochastic gradient descent is there, mini batch gradient descent is there. Nowadays they are using something called as the Adam optimizer. So these are the some of optimizers there which are used to update the weights. So two things are important over here. Yesterday we just saw, yes, what was there? Activation function that we need to define. Activation function. Second is optimizer. So which type of optimizer we are using? So there are certain names that we can use, but nowadays, like suppose for binary classification, sigmoid is used. For multi-class classification, which we are using, softmax we are using. For optimizer, we are having different options. Suppose gradient descent optimizer is there, stochastic gradient descent optimizer is there, stochastic, then mini batch gradient descent is there. Then there is something called the Adam. I will explain how this works, or what is the working of optimizers. So in backpropagation, what is happening in a backpropagation algorithm is a supervised learning algorithm used to train artificial neural network. So what actually it will do, it will help us to reduce the errors by adjusting the weight and bias. Okay, so it works by sending the errors backward from the output layer to the hidden layer, right? How is the structure? Suppose we are having these three inputs. What is there? Age is there, right? Second parameter, suppose x1, x2, x3. Blood pressure value is there. Then cholesterol value is there. These three inputs are there, correct? Then we are having something in the hidden layer, HL, and last one is a non-diabetic, diabetic, right? These neurons will be connected internally. Each neuron is connected to the next state. Okay, so you'll have this structure. Whatever is happening in this way, right? So this is known as the
Forward pass.
Forward propagation. Error is calculated, correct? Out of suppose 100 values, 80 are correct. So 80% is correct, 20% error. Then still you want to improve. So where are W1, W2 in hidden layer? W1, W2, W3 plus bias, plus bias, plus bias like this, right? Summation is there. So these weights will be updated through the what is used to update the weights? Optimizers are used to update the weights. So in forward pass, input data passes through the network, ANN produces output. After that, error calculation is there, which predict the output with compared actual output, right? Out of 100, suppose diabetic as a diabetic, non-diabetic as a non-diabetic, how many values are there? Same concept, correct? Whatever values, those are misclassified. Actually, it was a non-diabetic, but model has predicted diabetic. Actually, it was a diabetic, model has predicted non-diabetic this way, right? So error or loss is calculated. Error or loss. Sometimes it is called as the loss as well. Please keep in mind, sometimes it is called as the loss, sometimes it is called as the error. Okay, error and loss, these are the like similar terms. Error is propagated backward through the hidden layer and gradients are computed for each weight. Gradient means how much error is there. So that calculation is there and new weights and bias are updated to minimize the error. How this is happening, just please try to understand this formula, how actually it will work. Okay. So gradient descent is an optimization algorithm. Gradient descent is optimization algorithm which is giving you the optimized value of a weight. We will just focus on a weight right now. Same thing is used for a bias. We are just focusing on the weight right now. Same procedure will be followed for bias. We have seen, just try to recall the things for a linear regression. How linear regression work? We are just finding the optimized value of a m and c so that you will get a correct output. Y equal to mx plus c. What value will give in future? X value. We are having the optimized value of a m and c. So for any value of x, you can easily calculate a y. Is it? For any value of x, you can easily calculate a y based on the values of m and c. But those are found with the help of like multiple iterations. Best fitted line is there which is giving you the optimized value of m and c. Same way, here you will have a value of w and b which are optimized one with the help of a gradient descent optimizer. Number of optimizers are there. Right now we are just focusing on a gradient descent and which will give you the optimized value of a w and b. So right now we will just try to understand it for a w. Same procedure will be followed for b as well. So optimization algorithm which is used to train an artificial neural network which will help to minimize the error or loss function by updating the weights. Okay. So here error or loss will be minimized by updating the weights and the algorithm which moves step by step towards the minimum error value. Towards the minimum error value. I am just drawing one figure over here. How actually it will work. Just like try to focus on this. What we are having on x-axis, I am having something called as the bias or W, weight or bias on x-axis. On y-axis, it will have what value will be there? On x-axis, there will be a loss. There will be a loss. Okay, loss, that is a error. Loss, that is a error. Okay, so this work in this fashion. So some curve is there which converges to the downward position. Suppose if this curve is there, which will have some value of a w or b over here. Okay, on x-axis it will have some value, but this lowest point defining the minimum error. Lowest point defining the minimum error. How this is working? Initially it will have some value of a w. Initially it is having some value of a w. Suppose this is a w1. Suppose this is a w1 and next value will be w2, again w3, again w4, w5. So as per the iteration, value of a w is going to be increased, correct? Second iteration, w is going in a
decreasing
W is going in an increasing order, is it?
Decreasing, no, sir.
No, I'm talking about a W. W is on a x-axis,
Yes, sir.
correct?
Yes.
If it is going in this fashion, value of a W will go on a increasing, correct? If suppose value is this, correct? If value is this, W9 is there, right? What is happening in this side? In this
Decrease.
side, W is going to be decrease. But eventually, you will get some value of a W where these two curves will be intersected. Eventually, you will get some value of a W where this curve is intersected at this position, correct? So anyhow, you will get a minimum value of a W, sorry, optimum value of a W. This is nothing but not greater, not a lesser, right? You are getting optimum value of a W for minimum loss. You are just getting the value of a W for minimum loss. So after like multiple iterations, so algorithm moves step by step toward a minimum error value. Anyhow, you will get a minimum error there. Anyhow, you will get a minimum error there. How this will happen? What is the formula? W new equal to W old. W new equal to W old minus learning rate into derivative of error with respect to weight. Derivative of error with respect to weight. Just try to understand this formula. W new value, which is given with the help of W old minus learning rate. That is how this graph should converge. There is some value for the learning rate, which is generally 0.001. 0.001, which is helping us what can be the difference between these two values. So this should go smoothly, right? So if points are closer to each other, this graph will be smoother one, correct? If points are closer to each other, this graph will be smoother. If there is a large difference in a points, large distance, it can be something like this, correct? So in order to have a smooth graph, there should be some value. This coefficient is nothing but eta is nothing but a learning rate, which is like thousandth part of a 1, or we can say it is a 0.001 smallest value in order to get a smooth curve. Okay, so there should be no, what we can say, more difference or potential difference between the two values, W new and W old. Are you getting this? There should be a less difference, less distance between W and W2. If W1 is there, W2 is there, right? It will be joined something like this. But what will happen if W1 is there and W2 is something here? So that graph will be like, it will not give you the proper structure, or it will not converge properly. Is it okay? Is it okay for a eta value? Yes.
Yes, sir.
Is
Yes,
it
sir.
okay for it? Okay. Then what we will, how this graph will work? W new value we are finding with the help of a W old, but sometime it is going in a positive way, sometime it is going in a negative way. This is happening, correct? How this is going? It is going to the like meet at some level, right, where you will have minimum error, where you will have minimum error and optimum value of W. This is happening, but sometime it is moving to the right side, sometime it is moving to the left side. How it is happening? So what we are calculating, W old minus learning rate into derivative of E. So where is E on y axis, where is the W on x axis? So this derivative is nothing but a slope. This derivative is nothing but a slope. There is y2 minus y1 upon x2 minus x1. Whatever values between two errors. So this will give you the, so this is just a slope of two values. This is just a slope of two values. If you calculate this, suppose I just took w1 minus w2. Suppose this is, if I consider this one, you can easily calculate this. Obviously, it will have some x coordinate and y coordinate, correct? Obviously, it will have some x coordinate and y coordinate. So, what will be the x coordinate and y coordinate for this? Just try to calculate this. On one side, it will have negative slope. On other side, it will have positive slope. Is it? Or I need to like explain it with the help of numbers. Yes. Please tell me, guys.
Yes, sir.
Are you need to explain the numbers only, right?
Yes, sir.
Okay. Just a minute. Two triangles are there. Fine. So if I need to calculate the slope for this, suppose values are like, suppose here is x value is a 1, y value is a 2. Simple, right? X value is a 1, sorry, x1 value is a 1 and x2 will be 2. Same way, suppose y value is 5 over here and there will be 6, correct? Random number I am taking. Is it okay?
Yes.
Is it okay?
Yes, sir.
Yes, sir.
Or if it is on axis wise, if you are working on axis, how this is there? So this is like there, right? So if we plot on x-axis 1, 2, then 5, 6, simple, correct? So if I calculate the slope for this, what is y2 minus y1, x2 minus x1, y2 minus y1, x2 minus x1. What is x1? This is x1, x2. What is y1, y2, y1, y2? Is it correct? Is it okay? Correct.
Yes.
So this is a just keep in mind this hypotenuse is nothing but curve. Hypotenuse is nothing but curve. What will be the value of y2 minus y1 on left side? Y2 is 6 minus 5 divided by 2 minus 1. So this value will be 1, correct? 6 minus 5, 1. Any value you can work. Any value you can take, it will work like this. Is it? Is it? Same way. Same way. If it is on this side, if it is on this side, if it is on this side. So again, graph is like this, correct? So again, you will have some x1, x2, y1, y2 value, x1, x2, y1, y2 value. So here it will be x1, x2, again y1, y2. We can take different values. Suppose here is a 9, here is a 10. There is a 9, 10. So graph will be different in this case. X2 minus x1. Basically, it will go in a different fashion. Slope should be negative in one case, slope should be positive in another case. Okay, it is like this. Just a minute. Just a minute, guys. Just hold on. So if this is on this right side, just pay attention. If it is on this right side, just a minute. Okay, layer. So what will be the values if I'm taking this one? Just what is happening? If this is on this right side, Okay, so suppose triangle is like this. This is curve that is hypotenuse. If I take this y1, this will be a x1, correct? X1 y1, or if this curve is there, what will be the value? X1 y1 x2 y2, correct? Is it? We are
Yes,
taking
sir.
the coordinates for the curve, right? We are taking the coordinates for the curve. Suppose if we take this x2 y2, second point x2 y2, first one will be x1 y1. Same way, if this is second point is x1 y1, we need to take this as a x2
X2.
y2 and x1 y1, correct? What can be the coordinates? What can be the coordinates if we talk about the coordinates? If x1 is a 8, x2 will be 9, suppose. X2 will be 9. Same way, y1 is suppose 5 and 6. This way it will work. So what are the values for x1 y1 and x2 y2 now? What are
8.
the values for 8,
8.
9, 5, 6? So if we put this in the formula y1 minus y2 upon x2 minus x1, what will happen? What is the y2? That is a 9 only, right?
Yes, sir.
Minus 8. What is the x2?
Sir, reverse, I think so, sir.
Reverse. What is the y2? x1
Uh,
y1
6, 5.
6 5 or 5 6 x1 y1
There
x2
also
y1.
9 minus 8, sir. 8 minus 9. 9 minus 8. But it's x2 minus x1, right, sir? Hey, 8 minus 9, huh? Kindadi 6 minus 5. మామూలుగా
Yeah, it's completely like different in a first case. It's correct in this case. 9 minus 8. Okay, 9 minus 8 divided by 6 minus 5. So this will be a plus 1, correct? This
Yes,
will
sir.
be a plus 1. Is it okay for this right side? What will happen on a left side? Just see here one more time. So this will be suppose x1 y1 x2 y2, correct? Same fashion we will take. The same we have taken here. Suppose x1 y1 x2 y2. Same fashion if we take x1 y1 x2 y2, x1 y1 x2 y2, x1 y1 x2 y2. Is it okay? You can follow the same structure. We suppose upper point is x2 y2, lower point is x1 y1. So for this it was a positive. Is it okay for right side?
Yes, sir.
It was a positive. Now we will calculate it for a left side. Now we will calculate the slope for a left side. So what can be the values over here? What can be the values? X2 will be obviously. So this
8.
can be, suppose if we take x2 1, what will be the x1 in this case? 2 3
2.
something, correct? What will be like if I take y1 over here as a 5, y1 5, so it will be a 6 upper side. On y axis upper side will be a positive only, like more than a 5. Is it okay about values? Is it okay
Yes, sir.
everyone?
Yes, sir.
Right? So if I calculate on a left side slope, so here y2 minus y1 upon x2 minus x1. So what is the value of a y2? 6 minus 5. What is the value of a x2? That is 1 minus 2. So it will be 1 upon minus 1, that is equal to minus 1. Is it okay?
Yes, sir.
So on left side slope is a negative, on right side slope is a positive. Is it clear?
Yes, sir.
This thing happens. Okay, I just little bit I got confused regarding the values, but I hope now it's clear. I have
Yes, sir.
taken the value in the same fashion for a curve. You can reverse it like x2 y2 x1 y1. Here also x2 y2 x1 y1. You'll get negative slope on one side, positive slope on other side. That's the thing. This I want to clear. Is it okay?
Yes, sir.
Fine. Now, so what we are calculating new value of a weight based on the old value of a weight. But what we are doing in a, like, what is the second parameter over here? Eta into derivative of this error with respect to weight. So this is just a slope that we calculated. So on left side it is having a negative value for this. On right side it is having a positive value for this. Is it clear? On one side it is having a negative value. On one side it is having positive value. Yes. So if we put it into the formula, what is happening? So we'll get a new value of a W, sometime positive and some like more value than previous one and sometime less value than previous one. How? Suppose curve is like this, and why this curve is moving to the downward direction only, and you will get this value of a error which is the less one for optimum value of a W. How it will be there? Suppose what is the value of a W over here? So obviously it will be something called as the, suppose 2 value is there initially. What I am taking, W1 is equal to 2, correct? W2 will be new value, right now. Second value of a W will be W1 minus eta into this slope, correct? So W1, that is 2. W1 value is, what is the value of a W1? That is a 2. Yes.
Yes.
2 minus 0.001 something, and this slope value is negative on this side. The slope value is negative. We just got value something called as, like, suppose I just got -1, correct? So 2 minus of -1, that is +1, you will get a 3. So W2 will be +3. So we will get next value of a W2, that is a 3 on right side. Is it okay?
Yes, sir.
Fine. Next, suppose you are having something, suppose W weight is initialized like suppose 8 there, and we are having something value as a W10 is equal to 8. W10 is equal to 8. New value of, sorry, old value of a W is a W10 is equal to 8, and you are just calculating W11, new value of a W. That is W10 minus learning rate into this slope. If this slope is a positive, W10 minus 0.001, and this value is a positive, suppose 3 is there. So what you will get? 8 minus 3, that is equal to 5. Where that 5 will be? Here on left side. Yes, so it will move to the left. So anyhow this graph will converge at some time. Based on the slope value, this graph will converge somewhere where you will get minimum value of a error. So this process, this process is known as the gradient descent, where it will give you the optimized value of a W, and same process will be followed for a B as well. So whatever we are finding in a linear regression as a best fitted line, that is found here in a neural network with the help of a gradient descent, optimized value of a W and B in this equation, that is y equal to Wx plus B. Is it okay, guys?
Yes, sir.
This process is followed. I hope it is clear, everyone.
Yes.
Prema.
Yes, sir.
Yes, sir.
And sorry, guys, like sometime it happens, like, okay, whenever like I am explaining things, like little bit confusion is there, but I hope it is clear now.
Yes,
How this
sir.
will, more mathematics is there, so I just missed those values, how to take it, and it happened. Okay, but I hope there is no confusion now.
Yes, sir.
So what we initialize first, we initialize the weights, we calculate the prediction error, what is there, we just compute the gradient, and how we compute the gradient, that is also fine. Yes, just a slope of a error is there, right?
Yes, sir.
So just formula m is equal to W y2 minus y1 x2 minus x1, whatever we are using regularly in order to calculate the slope. Weights will be updated in opposite direction of a gradient, and repeat the process until and unless minimum error is achieved. Where that graph is like converged, or where that graph is like intersected, that point will be a minimum error, which will give you the this value is not maximum, not minimum, correct? W is
Yes.
not maximum one, not minimum, it's a optimum one. It's a optimum one. Yes. So this is how it will be calculated. So optimizers are using something like this. And next point is related to loss function. So what is the loss? What is the loss function?
Error.
Error, right? So whatever error is there, how to calculate a error? How to calculate a error? y actual minus
Original
y
minus.
y predicted, correct? So comparison of both the values or like difference of both the values will give you the error. So there are three loss functions in a regression and two loss functions for binary. So those are there in a machine learning. For neural network, this is something like different. Names are like more or less same. So loss function measures the difference between predicted and actual values in a ANN, right? So how many diabetic were there actually and how many diabetic predicted actually, right? So the difference will be given with the help of a loss function. So it will help us to determine how well the model is performing during a training, correct? So that we are testing with the help of some of the functions. So the main goal is to minimize the loss value. Yes, we have minimized the loss only here. What you have found over here? Minimum value of a loss. On x-axis we are having a loss or error, and you got a minimum value. So the common type of loss functions are like mean squared error is there for a regression problem.
Yeah.
For regression, we know already, right? Mean squared error, root mean square error, mean absolute error. So here mean squared error and absolute error is generally used. And for binary classification, what it is using?
Loss entropy.
Binary cross entropy. And for multi-class classification, it is using the categorical cross entropy. That's all. So what are these formulas? So you have idea about this formula, right? You have idea about this formula. So it is used commonly for regression problem which calculate the average squared difference is there. Yes, you know y square is there, right? So sometime value may be positive, sometime it may be negative. If some negative positive values are there, summation may become a zero. To avoid that situation, it is having squared value. And again same with absolute value, right? Same with absolute value where positive and negative will be considered as the same, only positive, right? So this is actual value y actual, and cap is nothing but predicted. Okay, so you have idea about this. Same loss functions will be used in order to calculate a error. For binary classification, what it is having? Minus of, so this minus is outside a bracket, y into log of y cap, y into log of y cap, y that is a actual value of a y that is a actual value of a y, log of a y cap that is a predicted value of a y, okay, plus 1 minus y. 1 minus y, that means a misclassified values. Or suppose y is for non-diabetic, y is for non-diabetic, what will be 1 minus y? Diabetic, correct?
Yes, sir.
Yes. So if y value is a 1, y value is a 0.6. So like probability of having a diabetic, that is a 0.6. What will be 1 minus y? 0.4 non-diabetic. So this is how it is working for a binary. And for a multi-class classification, it is having like same formula, but in a like different fashion. But it is not used over here or not given for the categorical, but there is no such a formula, but it will work on a probability, how classes are there, right? So iris setosa, versicolor, virginica, 0.6, 0.4, 0.0 will be there, correct? So your answer will be a setosa. If three answers are like 0.3, 0.35, again it will be a 0.35. So in this case it will be a tie, but most of the cases you will get values like 0.3, 0.34, 36 like this. So answer will be virginica like that, right? So these are the some loss functions. Again, please remember there is something called as the cost function. Sometimes this word is pronounced as a cost function. If you are calculating just like the just remember this thing. If you are calculating a error for a single value, only single value, it is called as the loss function. If you are calculating the loss for like multiple values and we are adding it, that is called as the cost function. Actually this is the cost function because we are taking a summation over here.
Yes, sir.
If we are having only single value and we are calculating a error, that is a loss function, that is considered as a loss function. If we are having a multiple records and we are calculating the multiple records error and we are adding at the end, that is called as the cost function. So sometime you can heard this word as a cost function as well. Okay, so ANN in machine learning is nothing but important part of a machine learning or artificial intelligence, which helps computer to learn a pattern, right, and relationships from the data, similar to the human brain. It just work as a human brain there, widely used in a prediction, classification, recognition, image recognition, decision making task, everywhere it is used. Okay, So where machine learning having application, there you can use ANN, and which automatically improve the performance through the training and learning. If we are using the same type of data in a machine learning and same type of data in a ANN, obviously ANN will give you the highest accuracy. Okay, so there are some roles for the ANN like feature extraction from the complex data, pattern recognition, classification, prediction and forecasting. Like in time series data, you can find its application. Again, data analysis, decision making is there, handling large and non-linear data sets, image face recognition, natural language processing, speech recognition. All these are the applications for ANN. If we compare ANN with traditional programming, so if we compare it with with traditional machine learning, so working principle is like just it learns from the past data and experience in ANN. It works based on the like predefined rule. Whatever rules we are defining, on that basis it is working. Learning uses training process to improve the performance. Unless and until you are not getting the less error, it continuously work iteratively, and it requires the manual programming. We need to provide the iterations, we need to provide work on the hyperparameters like that, so that we can improve the accuracy. If we talk about like problem handling, it handles the complex and non-linear problem, and traditional programming is best suited for the rule based programming. It can adapt for the new data easily, less flexible for changing data, or like if data is updating regularly. So traditional programming having some of the like faces challenges. Okay, applications used in all applications of AI and machine learning, and traditional is used in like standard software applications. Output or decision is made based on the predictions and decisions automatically. So most of the processes are automated over here in ANN, and which is there in a traditional, which produces the output based on the fixed logic. Whatever output is there, whatever logic is there. Suppose for a random forest, we are having specific output. For AdaBoost, it is working on a like basic principle, where if we need to update it, we need to like give some of the parameters in addition, right? Data requirement, large data set is required for the training in ANN. Okay, whereas in case of like regular machine learning, it works on like less data as well. Examples or like applications we can find in image recognition, speech processing, or self-driving car, like billing system, payroll, calculator. Creating these things, traditional programming can be used. So you will have like multiple applications there for the ANN. In all the cases, we are having some advantages as well as limitations for the same. So it learns from the past data or experience on a training, handle complex and non-linear problem. That is the like advantage of it. Accuracy is very high for both regression prediction, that is a regression classification. Works well with a large data set, supports parallel processing, same time it can work. Okay, as soon as we are providing a data, so it works continuously on the data to reduce the accuracy. And obviously if you are reduce the error, and ultimately it will increase the accuracy. Can automatically detect the hidden patterns in the data and give the insights. So multiple hidden layers are there which are updating weights and bias, okay, in order to get the improved accuracy. What is the like limitation or cons? Large amount of data is needed. It is not like that we are working on 100 records or like 1000 records. At least 10k records or like 15k 25k records is needed in order to train it. Training process can be time consuming some of the times. High computational cost is there. Resource complexity is there, like it is using a GPU. We are going to work on like Google Colab for this. We are not going to use a regular Jupyter notebook or local machine. So GPU requirement is there. Again, difficult to interpret internal working, like what is happening internally. That interpretation is a difficult. And again, there may be a overfitting, like it is learning well on the training side, but while execution there may be some of the challenges. And performance depend on the proper parameter tuning, which type of optimizer we are using, correct, how many neurons you are providing in hidden layers, that we need to define. So if all these things are good, you will get a good results. If we are like unable to provide some information at some level, then it may be like it may give the different results. Okay, so this is how it is working. Applications are everywhere in speech recognition. Whatever applications are there nowadays, they are using these neural network based models only. Image, facial recognition, medical diagnosis or healthcare, cancer, not cancer, again diabetic, non-diabetic, self-driving cars, fraud detection. Okay, in recommendation of like OTT or like whatever applications we are using right now, weather forecasting, stock market prediction, in every area you will find the application. So growth of a deep learning and artificial intelligence, so that this can be like a future scope for this. More advanced healthcare and medical system can be done. Improved autonomous vehicle or robotics is there. Smart cities, internet of thing applications, human like conversational AI system is there, right? So better automation in industries and business we can find for this. That can be a next thing. So all these things are there about artificial and neural network, guys. Any doubt till now? Prema, Bhavya, Saranya, is it
No.
okay
Yes, sir.
as a theory part? Okay.
Yes, sir.
So next session we will go with like implementation for this. We are having some customer churn data that we have not seen before. So that will be a new data for you, and same we will uh, mention in your resume as well. Okay. Same model. Okay. So is it okay?
Yes, sir.
Thank you, guys.